we'll talk about as far as systems go, being able to have control of the engines. Obviously, they're set up to run so that the aircraft is set up in such a way that the engines are trying to maintain 100% RPM, which is 264. All right, that equals 100% as far as how that movement goes. If one of the engines rolls back, we need to be able to control that based on fuel. So what we can do is we can take manual control of the engines by arming the manual trim, and we use these two rocker switches basically to tell small computers in the back how to program the fuel for that particular engine. So once we take control, for lack of a better term, the collective is in part our throttle. So once we arm manual trim, the computer knows to disregard how we move our throttle. All it wants to know is, you tell me where to set the fuel based on these rocker switches, and it will program the fuel control to maintain what we need it to maintain to keep the aircraft in control as far as the engines are concerned. So as part of that system, that was set up so that we could have manual control over each engine in case it went offline. This is our CDNU. It's kind of a all-purpose display. We can program our radios, GPS. It gives us engine information digitally, not just with the analog gauges, but with a digital readout from each engine as well. So we can kind of monitor what the engines are doing with this setup as well. So basically all of our avionics, as far as communications, navigation, and maintenance of the aircraft, can be accessed with these displays.
Okay, thank you.
Yeah.